Hi, welcome to the tutorial on understanding gradient descent. By the end of this tutorial, you will be able to explain what is gradient descent algorithm. So far we have learned what a linear regression model is, how it is prepared using the equation of a line, what the parameters of the line are, and how to find them for the best fit line in case of just one input variable. Now, towards the end of the previous topic, we mentioned that the manual approach we took to find the parameters of the best fit line in case of a single input variable would not work well in case of multiple input variables. And we would need to use gradient descent algorithm in case of a line in n-dimensional space. So, what is gradient descent? Formally, gradient descent algorithm is defined as an optimization algorithm that works iteratively and aims to find the minimum value of a convex function with respect to a set of parameters. Now, if you don't understand the definition, don't worry. Most of the students find it very difficult to understand it using the formal definition of gradient descent. We will look at the most intuitive example now. For this, I will go back to my college days. My friends and I often found ourselves in an argument that who is going to treat everyone in the canteen. To settle this argument, we often held a paper ball competition. In this paper ball competition, we were all given a set number of paper balls, and our objective was to throw as many paper balls as possible in the dustbin. The person with the lowest score, that is the person with the least number of balls in the dustbin, had to treat everyone that day. Now imagine that it is now your turn. Before you throw your first paper ball, you have no idea how much strength you need to use for a successful throw. So you random guess it to some degree, for example 30% of your strength, and you make an attempt to throw the ball into the dustbin. And if it falls somewhere in between, what do? You estimate how much the ball fell short of the dustbin, and then considering that, you readjust the strength needed to make a successful throw. So you make a second attempt with adjusted strength. Bad luck. Looks like you underestimated your strength. So you need to readjust your strength. So now you make a third attempt with the adjusted strength. And you finally score. But now your question would be, how this is all related to gradient descent algorithm? To answer this question, let's establish a step-by-step analogy between the gradient descent algorithm and the example we just discussed. In the first step, we had to guess the initial strength we should throw our paper ball with. In gradient descent, this step is known as random initialization. In the second step, we make an attempt to throw the ball into the dustbin with the guessed strength. Similarly, in gradient descent, we generate predictions using the randomly initialized parameters. In the third step, we estimated how far from the dustbin the paper ball fell. Similarly, in gradient descent, we calculate the error or the cost of predictions with respect to the actual or the true values. And in the fourth step, once we have calculated the distance of paper ball from the dustbin, we adjust our strength accordingly. Similarly, in gradient descent, using the cost or the error of predictions, we update the parameters of our model. Now the last step was to attempt throwing the paper ball again with the updated strength. Similarly, in gradient descent, we again generate predictions using the updated parameters. This iterative process keeps on counting until you start scoring, and the gradient descent finds a set of parameters that have the minimum cost possible. So that's all in this tutorial. We will learn about the steps involved in gradient descent algorithm in detail in the next tutorial. See you there.